All right, let's go ahead and get started. Excuse me. Good morning, good afternoon, good evening, depending on what part of the world you're joining us from. Welcome to this week's CA IDMS, excuse me again, educational series webcast. My name is Len Thompson. I'm CA's mainframe community manager. Welcome. Before we get started, just real quick, looks like almost all of you are joining this via the audio broadcast. That being the case, please use the Q&A box right in the WebEx to ask your questions. Please use the Q&A box rather than the chat. I'll be monitoring the Q&A, so any questions that come in, I will be able to facilitate. If you have questions throughout, please feel free to go ahead and use it, but Dick and I will hold all questions until the end to answer them then. And so with that out of the way, I'm going to hand you off to Dick Weiland, so take it away, Dick.
Thank you, Len. Good day, everybody. Bear with me a second here while I reposition our slides to today's starting point. So last week we finished our discussions on the enlarging of the database. We dealt with the reorg and convert page utilities. Today we're going to move into modifications of the database structure. And what we're looking at here, certainly enlarging the database is a modification, but this section is going to be looking at more or less the changing of the structure of the database, the contents of the database when those needs arise. So first of all, what are some of the reasons for changing the database? I think really if we look at this particular slide here, the first three are really some of your probably major reasons for changing the database structure. Changing user requirements. I mean, the applications are living, breathing types of things, and over a course of time, requirements for that application change. You may have to change the length of a field, maybe an address field, or a key field has got to be expanded, or some government regulation comes through that requires new elements to be added to the application. In some situations, besides the user requirements, you may be experiencing some type of user response time considerations. So you go through and you start looking at why are things slowing down a bit, and maybe what you decided is the structure of the database is no longer optimal for the types of processing that is required by the application or on that particular CV. So you may want to go through and make changes to the database structure that might further streamline the application's processing, or adjust again to the change on that user requirement that was slowing things down. And in many cases, that response time processing gets into a point of dealing with contentions. A lot of times sites will come through and the application will be running fine for a while, and then all of a sudden application volumes start increasing and they start getting deadlocks or stalls or just slowdowns. And some of that might be contentions of the database structure where two applications are trying to use the same record occurrences at the same points in time. So you start seeing more stalls or wait times, more DB key deadlock situations. So those three are probably the major reasons that you're going to go through and want to change the database structures. So the last four that we have on this particular slide really are, though they can be construed as reasons, they're really probably the way that you're going to resolve some of those other requirements. For example, you might want to redefine the distribution of sets across areas. Give you an example here. Let's say that you've got a calc record, and that calc record owns maybe 3 or 4 different types of records, and they're all defined as VIA, and so they're clustered around that particular record. But one of those records is very large in volume. So per each owner record, you might be having maybe a couple hundred, couple thousand member records for that set. So part of that VIA cluster gets very large and can result in some overflow problems when accessing all of the other record types. So maybe what you want to do now is take that record and move that record to a different area so that you can get a better clustering within the database for the other record types that that owner is the owner of for those particular sets. At points in time, you may have to remove records, sets, and areas, again, because the changes to the application have occurred, and those records may not be necessary anymore, or you may have to add new records based on those requirements. Also, that can go down to the individual data element levels within the structure. Finally, one of the other things that we will talk about here are, quickly are database procedures. And database procedures are exit routines, or you can think of them as exit routines within the database management system that you can code to perform different types of functions, and we'll talk about those in more detail later on within this section. But it may be necessary to add those procedures or remove them as, once again, the user or application requirements indicate. Now, as we go through and talk about this modification of the database, we're going to see that the operations that you're going to have to perform are basically going to fall into one of these three categories, or actually probably all of these three categories, and this, what you'll have to do. And the first of these is first change the necessary database definitions. So we're going to be talking about changing we'll point out the changes to the schema and the subschema. Then once you've made the changes to the definitions, you'll want to go through and change the data to fit the new database structure. So we'll be looking at different utilities and the types of changes that can be made by each one of those utilities to accommodate or implement that new database structure or definition. And then finally, one of the things we didn't have to worry about back when we were dealing with enlarging the database, because we didn't change any structural components of the database, but now that we also have to consider the fact that our programs are going to be expecting certain structures, records to be in certain areas in some cases, and when you make those changes, you're going to have to go through and make sure that the programs are now in sync with these different alterations that you've made. So you're going to have to go through and potentially revise and compile any of the programs that are affected by those changes. We're also going to have a little bit of a discussion within this section of the material to talk about when programs will have to be revised or maybe just recompiled to accommodate those changes. So the first place that you're going to be making changes for any of these structural alterations is within the schema. The definition of the schema, as we know it, is that entity which defines all of the records, sets, elements, and areas that make up a database. So if you're going to go through and remove a record, you update the schema to remove that record. Or to add a set, you add it within the schema. Now the schema is just a definition. It's just data, and it resides within the data dictionary. We do not use the schema at runtime. So it is just information that is placed in this special database called the data dictionary that defines the environment. So what you will do within that schema is you'll make the changes to create the new definition for your change, and then you'll validate the schema. Validation is necessary on a schema level because that is where we go through and we make sure that everything logically makes sense. So it is conceivable that you go through and you make a change and there might be some type of an error. Maybe you get the pointer positions for a set incorrect when you're adding them. Well, it's the validate that goes through and says, oh, wait a minute, you you use the same pointer twice for two different sets, or this record does not exist, as the record that you defined as a member of a set does not exist within the schema. So that validation process is necessary, and a schema cannot be used to generate subschemas unless that schema has been validated. So the next component that we're interested in is going to be the subschema. Now, the subschema is, as the name implies, a subset of the schema. And the subschema is what is going to be used at runtime. Where the schema was just a definition within the data dictionary, the subschema will also be defined or will be created in the data dictionary, but you will also generate each of your subschemas, and then those get created into a load module. It can be a load module in the dictionary load area, or it can be punch and link edited into an operating system data set, some type of a load library. So that subschema load module is then going to be invoked at runtime by the programs, and it's going to contain the information that tells that program, or it actually tells the database management system about the structure of that database. So if you come through and you modify the schema, your existing subschemas must reflect those changes as well. So in many cases, all you will have to do is just regenerate a subschema. But let's say that you go through and you've removed a record. Well, the subschemas that are there, you're going to have to remove the record from those subschemas. You're going to add a record or add a set. Well, in some of the subschemas that are going to be used to reference that new record or that new set, you're going to have to go through and add those particular entities to your individual subschema before you do your generation. So the major point that I want to bring about here is that the subschemas must be changed to reflect the schema changes. We'll talk when we deal with talking about what programs are going to be changed. We're going to be talking about also some of the coding of the subschemas, or how you might want to consider dealing with some of these subschemas to minimize some of the changes within your actual application programs as you go forward with these changes. Now, one of the points that I strongly want to mention here is that last bullet. Create a backup of all of your source code before making any changes. Again, the schema is just dictionary information. It's just record types like you create an accounts receivable database or a human resources database. So when you make a change, that change is in the database permanently. But now you come through and you say, I've got something messed up here, or we've got to back something out, we've got to go back to the old environment. You want to make sure that you still got that source available to you. So what I strongly recommend that you do is, before you make a change to the schema, use the schema compiler and do a punch of that particular subschema so that you get machine readable syntax, and save that off in some library or source system that you might have, say like an Endeavor or something like that, so that if you need it, you can go back and have that source, and you can recreate the various schema and subschemas that are necessary. Again, the subschemas can also be punched off using the subschema compiler. So I want to mention a bit here on the impact of the subschema changes. So again, the subschema is much like the schema from the standpoint that it's going to define the records, areas, elements, and sets that a particular database is going to contain. But now it is that subset that an application program is going to be dealing with. So within that subschema, just you have the records, areas, elements, and sets that are going to be available to an application program. So when you make those changes, you're going to to the schema, you must deal with the subschema or regenerate the subschema so that those changes are reflected in the subschema. There are also a couple other pieces that a subschema does have within there. There is a facility called Logical Record Facility, and if you are using Logical Record Facility, logical records are defined within the subschemas. So if you're making a change and you are using Logical Record Facility, you may have to make some type of syntactical change within the subschema to identify these logical records. Now, you also see on this slide we've got a bubble out there for security. Now, I want to point out that this is not the same security in terms of can a program be executed or can you sign on to the system or something where you might be using external security like ACF2 or Top Secret or RACF. This is a level of security that says through this particular subschema you can only read a record or you can only read a set, or you can do a read-write on the records. So it's kind of more or less, we actually in some of our other classes, we refer to this as kind of a privacy option. So those entities are also within the subschema. So anytime you make those changes, you are minimally going to want to regenerate subschemas, even if the changes to the database did not directly affect this a particular subschema or a specific subschema. Now, you may then have to go through and revise and recompile your application programs. So if an application program, let's say, does an area sweep of the order record, and the order record is in an area called ord-area. But for some reason, I'm not sure why, but let's say you have a reason that you want to move that order record into another area. We're going to call it Area X. Well, if the programs come through and they say, obtain next order within order area, and you're changing that order record into Area X, that program is going to have a failure because when it says obtain within order, obtain order within order area, it's going to say, well, I don't know anything about this record in that area. So the application program in that case may have to be actually revised to change that obtain statement. In some cases, let's say that all the program did was say obtain calc order and didn't care what area it was in. In those particular cases, all you may have to do is just recompile the program. Again, we will be talking about the application programs and those things that are going to require that revision and recompiling a little bit later. So we'll deal with this in more detail. Now, when you're updating your schemas, as I've been saying, you are going to have to go through and regenerate your subschemas. The schema compiler does have a nice statement within it or available to it called regenerate affected subschemas. So when you've gone through and you've modified your schema and you validated it, you can then do this regenerate affected subschemas. That will cause the compiler, the subschema compiler, to be invoked for each of the subschemas that are associated with the schema that has been modified. And we'll go through any validation processing for the subschemas and also go through and create your new load modules for each one of those subschemas. And those load modules will be placed into the dictionary load area. If you maintain your subschemas in load libraries, operating system load libraries, you will still be required to go through and punch those load modules and edit them into the load libs. So regenerate affected subschemas is not going to move subschema load modules into operating system load libs. It will only regenerate it into the dictionary load area. So once you've made your changes to the schema and subschema environment, we're going to want to go through and actually change the physical data. And there are basically three areas or sets of utilities that are going to be available to you for this. Now, we've looked at the first sub-bullet there, unload, reload, or reorg. We've already talked about these utilities from the standpoint of enlarging the database. But there are also operations or changes that can be made to the database using the unload, reload, or reorg utility. So we'll be looking at, again, at those utilities from the perspective of the changes that are going to be made to the database structure. We'll then also look at the Restructure and Restructure Connect utilities. This is the utility or two utilities that do the heavy lifting when you're actually going to go through and change structural components like the sets within the database or the records or the elements. So these are the utilities that will actually change the contents of the records. And then finally, changes to indexes can also be implemented through maintain index. We've also looked at maintain index from the perspective of enlarging indexes, but here we're going to be looking at some of the things that we can change, the definitional type things to indexes that can be changed, and we'll see that maintain index provides that type of process. So the first utility we want to look at are the unload and reload utilities and the types of changes that can be made with that. We're not going to go through as much detail as we did in terms of the running of the unload reload utilities, because this is going to be the same processing that you're going to go through. We'll talk about a few specifics here, but we really just want to focus on those types of things that can be changed using these utilities. So the first one, record types can be assigned to a different area. I gave you the example earlier of wanting to move one of the VIA records into another area because it had very large clusters. So that is something that could be implemented through unload reload. The unload would read it from the original area, and then the reload would place that record type in the new area and determine its placement in that area based on its VIA set within from the original owner or what have you. Record placement within an area. It is possible within IDMS to segregate a record into a sub-page range within an area, and under some conditions, maybe you've decided that you want to move that. Maybe get rid of the sub-page range segregation, or make the number of pages within the area that will contain this record greater or smaller. So again, that is the unload reload. The location mode can be changed within or using unload reload. This can actually, we're showing here calc to VIA. You can actually go VIA to calc. You may have to run the utility a couple times depending on what you're doing. But again, if you look at a record and say, I'd rather cluster this record around something else as opposed to being calc, unload reload will make those changes. It'll read the records as calc records, and when they store it, they'll be stored as VIA records clustered around the appropriate or specified owner record. VIA records that are members of more than one set can be relocated to be stored via another set. So let's say that you've got record A owns B, record C also owns B, and you decided initially when you defined the database that you wanted the occurrences of record B to be clustered around the owning occurrence of A. Well, during processing, you realize that maybe that wasn't the best decision, that it'd be more efficient to cluster the B records around C, the C owner, as opposed to the A. So again, unload reload will unload the existing database, and when it reloads it, cluster it around the new member. Index compression and number of entries per index block. This is something that a lot of times you may want to use maintain index because it can focus on an individual index, where unload reload is going to process more data and they take longer. But if you are making some other change to the database and you also want to change some of the characteristics, whether or not you're going to have compression on the index structure, or the number of entries you're going to have per index block. You can make those changes along with any of these other changes that unload reload is performing for you, so you wouldn't have to run a separate maintain index. So it will perform those same functions. And location of system-owned index. You can go through, one of the changes you may want to make is move an index out of a data area and put it into its own index area. This is something that a lot of sites do when they have large system-owned indexes, and from a performance standpoint, they decide to move that index structure to its own area. Again, this can be done through maintain index, but if there are other changes being made to the database, you can incorporate them along with those changes using the unload and reload utilities. Now, the reorg utility. We've talked about reorg basically is another kind of an offshoot of the unload reload process. So all of the things that we just talked about, all the processes that we just talked about that can be performed by unload reload are also available or can be implemented using the reorg utility. But reorg has been enhanced when it was created and can do a number of other things that can't be done using unload reload. First of these, add fields to an existing index provided the fields already exist in the record. Remember we said with unload, reload, or reorg, you can't add new elements into existing records. But if you have the requirement to change an index, let's say an index only had one element defined as a symbolic sort key for that index, but now you have a requirement to add another field and make that a concatenated field, as long as that new field already exists within the database record that is being indexed, you can run reorg, defining that index with the concatenated key, and reorg will build a new record, build a new database using that expanded key. In the same way, you can remove fields from the index. You cannot remove the field from the record, but you can change a concatenated key down to a single key, or just remove a single element from a concatenated key that has many elements in it. You can change the index from unsorted to sorted, once again, assuming that the key fields that you're going to define as the sort keys for the index already exist within the record. And you can also change the index from sorted to unsorted. Now, as I said, we're not going to go into a lot of detail with these utilities. You'll run them in the same manner that we talked about under the enlarging the database. But a couple considerations that you want to deal with. When we dealt with these utilities for enlarging the database, one of the things that we were really concerned with was number of pages within the area. That was our major concern. So that was a DMCL change. But now we may be making some of these other changes, like moving records to a different area or changing characteristics of an index. Those are pieces of information that are carried forward into the runtime environment through the SubSchema. So these utilities must specify both an old and new SubSchema. So the unload will be using the old SubSchema and taking the information from there, and then it will pass that information against a new SubSchema definition, and that will be used to determine what areas records go to and all these other characteristics. And then the reload will use the new SubSchema to actually reload the database. So you must have available to either of these utilities the old and the new SubSchema definitions. Now, Prior to making the reloaded database available for application use, any modified subschemas and programs must be migrated to the CV. This is a little bit different than we looked at before because the changes that we were making with enlarging the database had no impact on the subschema or the programs because nothing structural changed. All we did was add more pages into the database with these utilities. But now, before you can use that new database within a CV or even a local mode environment, the modified subschemas and programs must be moved into an environment so that when IDMS executes, it picks up the new copies of these subschemas and programs. Right. The next thing we want to talk about is, as I said, the guy that does the heavy lifting, and that's the Restructure Utility. The Restructure Utility is actually made up of two utilities. The Restructure is the one that will always be used, and it is the one that's going to make the major changes to a database. Restructure Connect is a utility that may have to be run based on changes to set definitions. So in some cases, it doesn't have to be run at all. In other cases, it is required, and we'll talk about those as we continue on. But just I want to talk here on this particular slide about the different types of changes that you can make through the Restructure Utility. So first one, insert new data items anywhere in the record. So if a government regulation comes through and says you now must have this new piece of data in your database, Restructure, and you've decided, oh, it's going to go into record type A, Restructure is the one that's going to place it into that element into the record. So it would increase the size of the record to accommodate that new record. Should also point that you can eliminate existing elements, so it would make the record smaller, but if you have an element that is no longer necessary and you want to eliminate it from the database, Restructure will do that. In many cases, I think users don't do this step too much. They just kind of ignore that element and leave it there, but if you want to reclaim that space for other usages, Restructure will get rid of that element. You can change the length and position of data elements. So if a field right now is defined as PICX10 and there's a new requirement that that field must be PICX20, you can use Restructure to make that change. You can also move an element around within a record for some reason. That means that, let's say, the record is at the end of, or the element, I'm sorry, is at the end of the record, and for some reason you may want to change it to reside earlier within the record. One of the reasons you might want to do this is there's something called a control length within the database. A control length is a portion of a record that cannot be compressed, and it must be stored on with the original root portion of a record when you have a variable length record. So let's say you're going to go through and change, you have a record that's compressed, and you have a data element that is your last element in the record. And you've decided that you want that element to become a key field for a sorted set or for an index, and you make that change. Well, now what you've done is you've made that entire record the control length. And the compression can't compress the control length of a record, or will not compress the control length of a record. So basically what you've just done is you change that into an uncompressed record. So to get some of the compression back, you may want to take that last element and move it earlier in the record so that a portion of that record is not in the control area of the record, and you still get a level of compression on that record. So one of the reasons for changing the positions. You can change a format of a record from fixed to variable or variable to fixed. You can add new sets. You can delete existing sets. You can add or delete prior or owner pointers for existing sets. You'll notice that we don't say anything about next pointers. If you have a set relationship, a set must minimally always have next pointers. So the prior and owner pointers are your optional pointers, and if at some point in time you determine that this database would be benefited by having prior pointers or owner pointers added to a set, Restructure will do that for you. Adding or removing certain types of database procedures. We'll be talking about this point specifically a little bit later on in this course material. But some of the database procedures may just go through and maybe they're just going to look at something within a field and say, oh, we're not going to allow you to access this particular occurrence because it's a celebrity, or maybe it's the President of the United States has a record on this database, so you don't want the President's record to go out to in certain individuals, or so you might have some type of security placed in there. Other procedures actually go through and modify the database. For example, compression. It actually changes the characteristics of the record on the database. So that first one that did just the security checking, it doesn't matter if you add or delete that database procedure from the perspective of running Restructure. But compression or some other type of thing that modifies the database may require that Restructure is run if you make the changes to the database. And then finally, I mentioned with the position of the records, the control portion of a record, you may want to change that control length, rearrange the fields so that that control length gets changed and has, very likely, a better compression ratio against an existing record. Now, here we're back to our overview diagrams for the utility, and you can see that Restructure is a little bit more complicated in terms of the pieces that are involved with using the Restructure utility. I should point out that all of the utilities that we have in here, and that includes this IDMS RSTT, they all take their input parameters from the sys IPT DD statement, and they all create output listings telling you what occurred through syslist, SYSLST. So some of those have been left off of this diagram just to keep it from being too cluttered. The Restructure utility and Restructure Connect utilities are actually utility statements, so they run under the control of IDMS BCF. They run locally. So your program will execute IDMS BCF, and the input statements through sys IPT indicate the fact that you're executing Restructure or Restructure Connect. Restructure utility updates the database in place. So it has read-write access to the database, and based on the types of changes, if you're making changes to sets, and in particular, if you're changing or adding prior pointers or owner pointers, a spill file is going to be required, and that writes information out to the spill file. The spill file must be defined to the DD, to the JCL if you're dealing with prior or owner. But if all you're doing is adding owner pointers, that DD statement, sys001, can be dummied because we really don't write any data that's necessary, but we still make sure that that DD statement is there. If you're adding prior pointers, then sys1 must actually define a real live sequential data set to which we will write information. That spill file is then used as input to the Restructure Connect utility, which updates the pointers within the existing sets, and so it also has read-write access to the database. Now, some changes to the database can't be finalized by the Restructure utility. For example, if you're adding a new field to a record, in that particular case, we can initialize that field with a single value. Let's say you say pick X5 as the new field. We can put all zeros in it, we can put blanks in it, we can put all A's in it, but we can't identify if there's a different value for each individual record occurrence that's on the database. Another change is if you're adding a brand new set. Restructure is not going to know what members are to be reconnected to what owners. So to accommodate those changes, you may have to create a user program. And that user program is just a standard user program like you would write for any other database update. So it also will have rewrite access to the database. We'll talk about that a little bit more as we come up. Now, restructure is actually driven by a table called the IDMS RSTT table, and you actually can give it a different name if you want. But that table must be created and then is passed on or made available to the Restructure Utility and Restructure Connect. To make life easier, we also have another utility, and we have also named that IDMS RSTT, and that will go through and generate the table for you. So that is another utility that you are probably going to want to run that before you do the Restructure or the Restructure Connect. And we will be looking at that as well in more detail. So a couple of things that I've talked about, a few of these, but we'll make sure we cover everything right now. The Restructure utilities are only used against non-SQL databases. If you have created an SQL database where you're doing a create schema, create table, and you specify the columns in the table, those databases are not modified or restructured using these utilities. Changes to those databases are done through SQL DD statements, and then in most cases in-flight restructures, which again we will be talking about some of those at the end of this section. I did mention Restructure utilities only run in batched local mode. So again, they are the only copy of IDMS that can be accessing that database during the restructure activity. Changes to the database are made in place. So IDMS reads a record, writes it back out there with the new characteristics that you've specified. Now, because that characteristic might be adding elements to a record, some of the records may become larger. And in some cases, that means that you might not have enough space on the page on which the record resides. To accommodate or to make sure that we can deal with that, you may see after a restructure some record types called SR2s and SR3s. These are what are known as relocated records. From an application perspective, they are transparent. Your programs, after a restructure, will access the database and have no knowledge that an SR2, SR3 exists on the database. And over time, IDMS tries to get rid of these SR2s and SR3s as space becomes available on different pages. However, after you run an SR2 or after you run a restructure, the SR2, SR3 occurrences can cause some additional I/O when accessing the records. So if you have gone through and you run a print space after a restructure and you see large numbers of SR2s, SR3s, you may want to consider doing an unload, reload, or a reorg of that database at some point to resolve and get rid of those SR2s and SR3s. In other words, we'll unload the database, and when we reload it, we'll go into normal overflow processing. So just, if you see these SR2s, SR3s, there's a bit of a concern from a performance standpoint, but from the execution of the application, they will not impact the application's ability to process the database. As we saw with a number of our other utilities, logically deleted records are not allowed in a database. when the restructure is to be run. So one of the steps is going to be to go through and run your print space, look for logically deleted records, and if any exist on that database, you're going to want to run the cleanup utility. And then finally, a point that I did mention, the base restructuring module, IDMS RSTT, is used for the template for the physical changes. So that it is user's responsibility to create that module, and again, you will be able to use that IDMS RSTT utility to generate that information. So as I pointed out, Restructure drives the actual physical changes using IDMS RSTT as a template. If a prior pointer is being added to an existing set, then the sys001 DD name must specify a sequential file, and we will write all the information we need to connect those prior pointers to those existing sets. If you are adding owner pointers, the sys001 DD statement must be there, but you can dummy it because we're not going to write anything to it. And so when we go to the connect, you can also pass that dummy file to it. It will look for it, but it doesn't require any data out there to resolve the owner pointers. Only prior pointers being added to an existing set. And Restructure uses the SubSchema with the original view of the database. It's going to go through and make DML commands to read the records, and those DML commands must be able to recognize the characteristics of the records and sets based on what is on the database currently. So that is why you must use the original view of the database. The Restructure Connect utility needs only be run if you added prior pointers to an existing set or owner pointers. This utility comes through and reads the spill file through also sys001 DD name, and if it finds an empty file, in other words, let's say I dummied it because I was just adding owner pointers, it recognizes the fact from using that IDMS RSTT template that owner pointers were implemented or added to the database, and it will go through and connect the owner pointers because the way it processes it, it can know the owners for each one of the individual members. But if the prior pointers are there, it's going to go through and read the information, identifying the sequence of the records in that prior direction in which it's to connect the record. And Restructure Connect uses a subschema that defines the new structure of the database. So Restructure went through and created the new lengths for all the records and all the prefixes of the records. So that is what the DML commands that Restructure Connect issues are going to encounter on the database. So that subschema must be the new structure of the database. A user-written program may be required. The user-written program is going to be necessary to populate new data fields or possibly the expanded portions of existing fields. We will go through, as I said, and put out a default value, which is specified through the IDMS RSTT. However, if there are different values, you want something other than all spaces or all A's or all zeros, then your user-written program is going to have to go through and access that particular database and make the appropriate changes to those portions of or new fields or portions of new fields. The connect member, or it's also used to connect member records to newly added sets. So we can put in the prefix positions for the owner and the member records, but we can't go through and identify which of the members belong to which owners. So that is the knowledge that you would code into your user record to be able to say, this order belongs to this customer. And so you would do the connection. This program is just like any other user-written program. It uses standard, you're going to write it using standard DML commands, obtains, modifies, finds, what have you. And it can be run either locally or through the CV. And of course, it's going to use the new subschema definition. So, the steps to run the Restructure utility. First of all, create your new database definition. So that gets into creating and modifying the subschema and then regenerating all the subschemas as we talked about earlier. You'll create the IDMS RSTT module, and the utility that we'll use for that is IDMS RSTC. We'll vary the areas to be modified off of the CV. Again, the main thing here is that, again, the restructure can be the only IDMS access to those areas during the restructure. So it can't be active to any other programs in local or to any CVs. And this includes also retrieval, because you're changing the structure. So you're not going to be able, you're going to have some records that are shorter, some records that are longer because of just the sequence that we're executing or processing the records. So it can't even be in retrieval like we did in some other cases. Back up the affected areas. Again, you want to make sure that you can fall back if there's some type of a problem. You'll run the Restructure utility. And then if prior or owner pointers are added to any existing set, you'll want to run the Restructure Connect utility. If the new sets were added or current specific values of the fields are required, this is where you would then run your user-written program to update the new fields, the new elements, or make connections to new sets. Number 8, you want to validate that database. So once again, run print space, run dban, run OLQ using the new subschemas. Do something to exercise that database to make sure that everything looks as you intended it to look. You'll want to back up the affected areas so that if you start processing and then there is some application reason why you're going to have to recover the database back to the point of the restructure, in other words, the restructure was good, but there's some logical reason for recovering the database, you want to make sure that you can go back to the newly restructured database without having to go back before the restructure and then rerun the restructure. You'll migrate your new subschemas and any modified programs to your runtime environment, and then you can vary your areas back into an update mode against the CV. Okay. Well, we're 5 minutes to the hour, so I think this is a good point to cut the presentation for today, and we can spend the rest of the time taking any questions that exist.
Thanks, Dick. Thanks, Dick. I really appreciate it. I don't see any questions coming in at this point, but just a reminder, folks, please use the Q&A box to ask any questions you might have. And a couple of you are on the phone line, so if you are and you have a question, please feel free to hit #6 to unmute your line and ask your questions verbally. And we'll give you a moment to do that. And while we're waiting for someone to type, if they are typing, a quick reminder that I am publishing all of the replays of this entire educational series out in the community, so you can go out there and look for them there. And over the next couple of days, I'm also going to be creating a landing page that will link to all of them all in one place to make it a little bit easier for you. So I'll be doing that in the next business day or so. All right, a question did just come in. A couple questions came in. All right, we'll see if we can get through both of these before the top of the hour. First one is, you mentioned a reorg. Is this something new, or were you just referring to an unload/load?
No, reorg is a utility, is a relatively new utility. It was created back about release 16, 17, and it is an additional utility that can perform the same types of functions for unload reload, but it can do it in a shorter period of time. We spent, you may want to go back and look at last week's presentation where we went through and discussed the reorg, really focused about an hour, most of that hour on the reorg utility. but it is a utility that's been around since at least 17, release 17.
And the other question is, I have the requirement to add a new IDMS via record from one of the CALC records to use with the existing set name. I created a new VIA record using the IDDM and verified the IDD before to modify schema and subschema in the dictionary. Then I did the modify schema and subschema to add record. Oh, hold on, it's coming in quick. And mod set name to the existing IDMS area. Everything is fine with batch job RC equals 0. But then when I validated the result through OLQ, and I received the IDMS error code 0353. To fix the above IDMS error code, then I worked on a restructure of the database unload reload utility. I was working the requirement to add, modify, remove many of IDMS records in both CALC, BIA, and set names to the existing or new IDMS areas. And then I just got back search and then able to understand we never done to add, modify, remove the IDMS record or set name for many years. So I don't know if you know what this question means, Dick.
I kind of, but I think the scope of what you did is would need quite a bit more analysis of what occurred. I will say that when you're doing, and I'm not clear on all of the steps that you did take, but it sounds like you tried to make a change to the schema, subschema, and then you tried to use OLQ against that, and you got an 0353. A 53 minor code can tell you that the definition of a record or an index, it might be a record's length or a characteristic of an index, does not, on the database, does not match the subschema. So if you went through and you did if you modified the schema and subschemas and then you tried to use OLQ, I would certainly expect that you would get error messages with 53 minor codes. You would have to do the restructures before you could actually do the validation steps. A lot of the different pieces there was very hard to follow, and like I said, it would be a very this would be a little bit of a protracted discussion. I would suggest that if you are having problems with that restructure process and adding these via records, that you would open a case with level 1, and they could, give the scenario of what was done, and they could walk you through that. But the main thing here is that that 53 minor code, it sounds like you tried to do a validation on the changes to the schema subschema before you did a restructure or rebuilt that, or modified the physical portion of the database. And I think that's about all within the scope that we can do within this class.
All right, thanks, Dick. I don't see any other questions, and it doesn't sound like we have any on the audio. Plus, we're at the top of the hour, so we can go ahead and wrap up. Dick, thank you very much, as always. And to those of you who took time out of your day to join us, we really appreciate it. We hope you learned something today. And again, the replay of this session, if you want to share it with your colleagues, will be out in the community either later today or on Monday. And again, we think we have 2 or 3 more weeks of these sessions, so we hope to see you next time.
For 2, I believe.
2 more? Okay. All right. So 2 more sessions the next 2 Fridays. So we'll see you then. And thanks very much. Bye, everybody.